electric vertical takeoff and landing, or eVTOL, vehicles represent a transformative advancement in the aviation industry. These aircraft, designed to take off, hover, and land vertically, leverage electric propulsion systems and cutting-edge aerodynamics, distinguishing them from traditional helicopters and fixed-wing planes. eVTOLs are at the forefront of discussions surrounding urban air mobility, emergency response, logistics, and environmental sustainability due to their potential to reduce emissions and noise pollution while offering efficient, flexible transportation. First, flight range. Most eVTOLs currently being developed have a flight range of 50 to 150 miles, depending on battery capacity and the specific design of the vehicle. For example, Joby Aviation's eVTOL is expected to cover around 150 miles on a single charge. In comparison, traditional helicopters have a typical range of 250 to 400 miles. Next is about speed. eVTOLs are generally designed to travel at speeds between 100 to 200 miles per hour. Then, electric propulsion. eVTOLs are powered by electric motors, offering a more eco-friendly alternative to traditional fossil fuel-based aviation. They are expected to drastically reduce emissions in the aviation sector. Also, vertical takeoff and landing. The ability to take off and land vertically allows eVTOLs to operate in urban settings with limited space, such as rooftops or dedicated vertiports, avoiding the need for runways. Moreover, autonomy and pilot assistance. Many eVTOLs are being designed with varying degrees of autonomy, from piloted models to fully autonomous systems, aiming to reduce the need for highly skilled pilots and streamline operations. Finally, battery technology. Advancements in battery density and performance are critical to eVTOL success, as longer flight ranges and quicker charging times are essential for commercial viability. First, commercialization and certification progress. Several prominent companies are vying for early certification, aiming to introduce their aircraft by 2025. Joby Aviation, an industry leader, is advancing toward Federal Aviation Administration certification and recently conducted successful test flights. Their aircraft is projected to carry up to 4 passengers with a pilot, covering a range of approximately 150 miles on a single charge. Lilium and Archer Aviation are other major players, also working closely with regulators to ensure their designs meet safety and operational standards. Next, infrastructure developments. Companies such as Urban Airport are developing the necessary infrastructure to support eVTOL operations, particularly in urban centers. Vertiports equipped with charging stations and facilities for passenger boarding are expected to be strategically positioned in cities to facilitate urban air mobility. Governments and regulatory bodies in countries like the United States, United Kingdom, and Japan are drafting policies to accommodate eVTOL flights, including airspace management, safety protocols, and licensing standards. Then, partnerships and investments. The eVTOL space has seen significant investment from both private and public sectors. United Airlines, for example, has invested in Archer Aviation, and Hyundai has partnered with companies to develop eVTOL prototypes and urban air mobility infrastructure. Governments are also beginning to allocate funds to promote the development of air mobility ecosystems. In 2023, Japan's Ministry of Land, Infrastructure, Transport and Tourism launched initiatives to create eVTOL testing zones, further boosting industry momentum. Finally, testing and early use cases. While most eVTOLs are still in the testing phase, certain applications like air cargo and medical transportation are emerging as early use cases. Volocopter has made strides in cargo eVTOLs, planning to launch services in densely populated regions of Asia, where ground traffic poses significant challenges. Emergency medical services could benefit from eVTOL technology, offering faster and more direct routes to hospitals, especially in areas where road congestion could delay critical care. Firstly, regulatory hurdles. Although eVTOL certification is progressing, regulatory frameworks must be fully developed to ensure the safety of these new types of aircraft. Airspace management, traffic control systems, and safety standards for autonomous flights are among the critical areas requiring refinement. Next, battery limitations. Current battery technology still presents limitations in range, weight, and charging time, making long-distance flights less feasible. Research into more energy-dense batteries or hybrid systems may be needed to overcome this barrier. Then, with any new technology, public acceptance will play a significant role in the success of eVTOL. Concerns over safety, noise, and privacy could hinder widespread adoption, especially in densely populated urban environments. Finally, cost and accessibility. While eVTOLs are expected to be more cost-efficient than helicopters, the initial costs of operation, infrastructure development, and certification could make them accessible only to a limited demographic in the early stages. If you know more about any of these initiatives, please leave it in the comments section. Thank you for watching this video. I'll catch up with you in another exciting video soon. Until then, goodbye and take care.